This puzzle is called Arrow of Anti-Chaos by Infinity Gamer 00. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look at the rules. So this is another chaos construction puzzle. So digits can't repeat in rows or columns, but we have to figure out the regions ourselves. We're going to have to build all 4 regions, figure out where they are. So arrow. Digits along an arrow must sum to the arrow circle. Yep, that's just normal arrow Sudoku. So if this was, let's say, a 1 and a 3, 1 plus 3 is 4, so the circle would have to have a 4 in it. Pretty simple rule there. Each part of the arrow must be in a different region. For instance, row 1, column 1, row 1, column 2, and row 2, column 2 must all be in different regions. Okay. That is fine. Anti-V. Digits, sorry, yeah, cells that are orthogonally connected must not sum to 5. So normally, obviously, you could have a 2 and a 3 next to each other, but in this case, you cannot have that because 2 plus 3 equals 5, the other one being 1 and 4, obviously. Those don't work. You can't put them next to each other. Circles, row 1, column 1, and row 4, column 1 indicate the number of cells in that circle's region that can be seen in that row or column, including itself. Okay, so that's similar to the Analytical Ninja puzzle I literally just finished. So let's take a look at that. So if this was a 3, let's say, and we'll make it yellow, that means this circle sees 3 of the 4 yellow cells of the region. So it could go something like this, and then the 4th cell would have to be in one of these 2 spots because this could not be yellow and this could not be yellow because it sees exactly 3 yellows. So this would be a valid region for yellow based just solely on this number 3. Or this would also work. If this was a 4, it could go something like this, and that would be fine, or it could go just flat across the bottom. That would also work. Yeah, there's just a lot of different options there. I do not know how hard this puzzle is. This does seem pretty tricky, but we'll see. What was I going to say? Oh, I'll put a link to the puzzle down in the description if you want to give it a try yourself. And yeah, let's just hop in. I think the first thing is to color these regions. Because we know one of the rules says, yeah, each part of the arrow must be in a different region. So I think this is what we should do first. I don't think this one is necessarily in a different region than any of those. Although I think we do know that this cell is in a different region. Green is only 4 cells large, obviously, because each region is only 4 cell large. It cannot reach down to this corner no matter how hard I try. So this must be in the 4th region. Now, unfortunately, this could reach here, or green could reach here, or... No, yellow could not reach here. This cannot be yellow. If yellow went like this, then both of these circles would see the same number of cells. They would both see 4, which would mean both of these would have to be 4, which would be a problem. So this is blue or green, but we can't do any better than that, at least right off the bat. I guess yellow has to come to here and has to come to here. Because yellow has to escape, because yellow has to take 4 cells total. So it actually has to be like this. Because it can't take this, because that would be too many cells. They would see both the same cells, we just went over. Pink has to go here, green has to go here. This is making it harder for green to hit down here, huh? So this has to be pink, this has to be pink. This has to be green. Now we have some choices. Well, green can't hit here anymore, so this has to be blue, which means blue has to connect. So this has to be green. Okay. Now we can fill this in. This sees 3, this sees 4. Just fine. Yeah, that's what we expected. Although we didn't... Yeah. So this is a 1-2 pair. The 3 in pink has to go here, and then here in green, and then here in blue. The 4 in yellow has to go here, and then here, and then here. But now we have a bunch of 1 2s. What can we do with these 1s and 2s? Oh, right, the anti-V constraint. Cells that are orthogonally connected must not sum to a 5. Yeah, I totally forgot about that. So we can't put a 1 next to a 4, so these are all 2s. These have to be 1s because they're next to a 3. These also have to be 1s because they're next to a 3, and that's a 2. There we go. That didn't turn out to be as tricky as I thought it would be. This arrow was actually gave us a lot more information than I initially thought. But that was very fun. I really liked that puzzle. I like the chaos construction in general, but also combined with like a 4x4. So it's not too tricky because chaos construction, as you could probably figure, can get very difficult very quickly. But yeah, just a 4x4 kind of keeps the the ceiling of difficulty pretty low because it's a 4x4. There's only 4 options for each cell, right? But that was a very fun puzzle. Thank you, Infinity Gamers, for that puzzle, and thank you all for watching.